Anybody who's followed the animal die-offs know that the die-offs have been getting worse with each successive year. The megatons of vertebrates and mollusks that have come washing ashore is staggering. You're talking hundreds of thousands of tons of dead animals washing up on beaches. If you don't believe me, please ask for the list. And the wildlife managers along the Oregon coast, Alaska coast, talk about the birds die-offs. Now the seals are dying. I mean, come on, guys. We know why. And there's a lot going on, but it's all related. And we talked about the radiation being very dangerous to children and yourselves if you're out in the sun. We know that all this radiation that people are measuring and talking about, and all the forest fires and all the heat coming from particle interaction. One of those particle interactions we made a video on about electron exchange. Today we're talking about collision, because collision creates extreme ultraviolet. No, we're not talking about athlete's foot and acne. We're talking about inflaming your brainstem so that you can die just taking narcotics that you normally are used to taking, because they depress the activity on the brain that's inflamed already. And the particles that are doing all the damage are known as neutral helium, and it's kind of like what you have in your helium balloon, only it's heated to 3,000 degrees, and it's traveling like a wind. And it's traveling at 25 kilometers a second, if not faster. And they have an article that measured the helium for a very specific time period, plotted the land and sea surface temperatures, because those are more reliable than air temperatures. And they were able to draw an exact correlation between the amount of helium being measured in the satellites and the temperature of the ground on Earth. They found 18 fluxing variations that matched the temperature variations. This cosmic radiation used to get a lot of press and a lot of coverage in the scientific community until they found out it was coming from a brown dwarf that may already be inside our solar system. I know it sounds crazy. Look at the sun, go lay out. You ask me if the sun's any hotter or not. Well, there's why. The corona is lighting up. And here I'm showing you abstracts of just some of the hundreds of articles done on the helium. Many of these were done in the 80s. Some of them were done in the 90s. Some of them were done in the early 2000 and mid 2000. But they're all talking about what? The helium. And so it's there. And the reason I put this up so much with purpose, and over again, is because we're actually trying to weed out who the fraudulent people are in this forum. Who's deceiving you? Who's hiding things from you but acting like an expert? Because this stuff injures people, and there's damages to be made and to be recovered. And this stuff has damaged and hurt more people than any single event on the planet Earth, including the great tsunami of Christmas Eve. And these gentlemen drew a correlation that was so exact and so much like a thumbprint on a thumb that there was no denying it, but yet they still come under criticism. And one of the criticisms was, well, the study's old. Well, there's a lot of old theories out there from Einstein, Newton, and all kinds of people that are still standing, and nobody's proved them wrong yet. And so when you can't prove this study wrong, all you can do is try to cover it up. A more recent study, I do believe, trying to figure out 2007, 2008 ice anomalies, correlated that cosmic rays were at its lowest during the time frame I just showed you, where we had the greatest loss of ice during a solar minimum ever in the history of our planet. And this radiation is dangerous. It's very, very dangerous. The 160 nanometer will show you what makes it so dangerous. Is that it can penetrate skin and damage DNA in chunks of DNA at a time, not just one little bonding site on a single DNA thread. But this correlation is just so exact that the red is helium, the blue is temperatures, and you can see almost an exact correlation during the time frame taken. So there's probably a 90-degree confidence that correlation still exists with neutral helium. And indeed, right now, our ice pack is at its lowest level ever for this month. What do you think it's going to be next month? You think they'll gain ice? And the thing about this graph is, they looked at it 9 different ways and smoothed this and it blew up that, and it really does seem there's a correlation to the helium. And then we go to the actual instrument. I don't want to tell you the name of this instrument because I'm afraid they'll pull it down. This is a plastic instrument. It has a plastic sheet that measures impacts and counts helium. And the normal interplanetary background for helium was down there around 0.1. And we're seeing an almost tenfold increase in helium. And you can bet that graph's going down. Here's the radiation at the top and the bottom of the atmosphere. So you don't need me to be a fear monger. Here's proof. Okay, at the top of the atmosphere, you see in the red line, you see almost 300 CPMs, clicks per minute. I got news for you. Highest background should be 35 CPMs as your normal background radiation. That's the highest it should be. Indoors should always be lower than that, half that. But then down in lower altitude, you're seeing readings of around 100 CPMs to 150 CPMs. Again, clicks per minute. Clicks are the number of particles that hit your instrument. It has nothing to do with this ultraviolet C and the gamma radiation and the X-rays that are coming in already. These are particles. The P stands for particle in CPM. They can take a machine and measure your photon radiation, and that can be converted into CPMs, but that conversion is not good anymore because so many neutrons are coming in. Neutrons carry twice the CPM value as uranium, cesium, iodine, radioactive ones, isotopic. And so we want to know what's causing this increase in background radiation. And it helps to distinguish between gamma and ultraviolet C and extreme ultraviolet. But the thing I'm with purpose trying to do is show you who's the liars are, because they are dangerous people and have injured millions. Collectively, as a group, as an information group, disinformation group. So this is an article about measuring what? Helium particles. The original temperature of interstellar helium, they think, was 11,000 degrees Kelvin, coming off the star, cooling down to 3,000 degree Kelvin when it gets inside our bow compression zone. And most of these articles are about that, the radiation levels. So when your planets are brightening, your moon is brightening, Everything's brightening, brightening, brightening. You can't just say only one planet can brighten and the rest can't. You really, in physics, that would just blow physics out of the water. And those of you who say, well, if Planet X came by Neptune, Neptune would have a lot of debris and maybe even rings. It wouldn't just remain as it looks. And that's true. That is true. But don't think that these rings aren't crowded. It's one of the more crowded rings we see. But there's some really extreme stuff going on. Now, you guys, so if the moon's brighter, it's because the sun's brighter. If the sun's brighter, I mean, we showed you an instrument that proved the visible light on the sun is up by billions of watts. So if there's more light, it has to go somewhere. And if you put a bigger light bulb in the room, more things are going to shine brighter in that room. And if you're talking about our sun, you're talking about all the planets should be shining brighter unless they're enveloped in this helium cloud that absorbs and scatters orange light and green light. But people had been documenting the changes in all the planets. They've been writing about it and reporting about it. A lot of it was foreign stuff. Other astronomers, Russian, Japanese, etc. But they've been chronicling how Neptune's been getting brighter, and Neptune is the closest planet to this brown dwarf that I've been referring to all these years. And I want to tell you something. You didn't see the word brown dwarf in many titles. And we spent 3 years selling not only that we knew where the brown dwarf was, and we were correct actually, and what it was doing, we made dozens, if not hundreds, of predictions based upon its position. And now the experts, the astronomers, were documenting its brightness in the planet, and they theorized that it was going into spring in roughly a 150-year orbit. That's a pretty short spring or a pretty quick onset. And I did not know that spring made your entire planet glow. That's something new to me. Gotta kind of find the physics behind that. No, we'll just throw the theory out there. It's springtime on Neptune. Never mind, it's at its furthest point from the sun right now. At least if it conforms to all the other planets. And, in 6 years, significant brightening and changes in the atmosphere itself. And if something affects the brightness of one object, it's going to affect the brightness of all objects. And that's what we have seen. So anybody who tells you that Venus isn't brighter, you show them Neptune is brighter and tell them, happy spring. And the moon is brighter. You can see the entire moon. You can see all the structures on the moon during an early crescent. And the early crescent, you couldn't even used to see at all. Everything's getting brighter. Anybody who tells you Venus isn't getting brighter, you're offended, because remember that time the airline pilot reported a plane was bearing down on him? And it turned out to be the planet Venus, because at certain times during this last solar maximum, it was the brightest you would ever see it, and always did look like an airliner was landing on your street. So one planet gets brighter, they all got to get brighter. The problem is, as soon as they figured out why, you notice you don't see anything after 2002. I try to find it. I can't. Maybe you could find it. So all you got to find is amateur stuff. And they were right. Venus has since dimmed because we passed between it and that cloud. The object is moving away. That's Neptune, I mean. And Neptune should be brightening and turning back to its blue color, hopefully this year. But we'll see. I don't know. We'll see. The neutron counts, there's a reason the neutron counts run higher in the South Pole than the North Pole. First of all, they're neutral. So they're not affected by the magnetic field. So they come in from where they came in from, and they're coming in from the south. Therefore, you have more particle interaction and collision in the southern hemisphere, and you have extreme neutron counts, sometimes 111, 120,000 neutrons per meter or square meter. But we were also we were trying to determine if we were going to hit a pocket in this helium wind. And if that pocket would show up, we would know where the position of this brown dwarf had moved to. And we're looking for it to obey a well-known model that was mapped by a naval astronomer and 70,000 computers. And we saw the bottoming out of the very blue line at the bottom. That's your KP index. That's your geomagnetic storms. And we see them bottoming out early. We used to see them bottom out in mid-February. And then in late February, we would come out from behind that pocket and get slammed by a solar wind. Seems like everything has shifted. The earthquakes did this as well. So this puts this thing more under Saturn now. So you want to go 20 degrees south of Saturn. Due south of Saturn, towards our South Pole. And if you have a infrared binoculars, you're looking for a glow that you can't see with your naked eye. But the neutron counts have been going up, and they go up and down according to solar max or solar min. Solar minimum is supposed to let more neutrons in. And they theorize that the weak magnetics on the sun allow more particles to come out of the sun and collide with our particles in our atmospheres where neutrons have to be created because they have such a short life. They can't make it here from the sun. No matter what conspiracy they're saying about the sun. And the issue we're looking at then is a steady decline. So we want to see a more long-term graphed out KP index, accounting to see what the patterns are. But it's just ironic that every time we try to say this thing moved more towards the west and south, all the evidence we find doesn't contradict it. In fact, it supports it. And I want to tell you something. I put out a video saying Planet X and making a final approach, final dive. And I want to tell you, within a week, there was 12 other titles that were like that on these other channels. Just want to let you know. And so when you go to Google or YouTube, my title, you could see where the information on these graphs get washed out with a bunch of lens flare channels that all use the same title. Don't think there isn't purpose, but you meet purpose with purpose, and that's all that you can do. And if you've lived long enough and had a good life, then you don't care what they do to you. You really don't. You try to be smart, but we're talking about particle collision. We're not talking about electron exchange. We're not talking about interaction. We're talking about particles slapping into one another. In our atmosphere, it creates these sprites. And it's very, very rare, but they're occurring more and more now because the density of particles are becoming more concentrated. When they slam into each other, we get lots of ultraviolet. We really do. We get visible light, ultraviolet. And this spectrum showing you right now looks like ultraviolet A. And ultraviolet A, the far right hand of the graph, this is an instrument and a satellite that measures the sun. Solar minimum, far right graph, the ultraviolet A is billions of watts higher this solar minimum than last solar minimum in 2007, 2008. That's right, billions, if not trillions. Now I'm going with billions, hundreds of billions of watts. And that hundreds of billions, that figure of extra watts coming off the sun, that figure is just for the ultraviolet A energy and not any of the other energies that are in increase as well. In the end, you may have over 1 trillion more watts coming off the sun than ever has come off the sun before. Fifth grade science says the hotter anything is, it goes from yellow to white to blue. But we're talking fusion, maybe. No, particle interaction. We know why the sun's white. So articles existed about this helium back when people were calling me a con man for just saying there was helium. Everybody that I know of, except for maybe 1 or 2 people, denied the helium or never spoke a word of the helium. And when you shine visible light through helium, what obvious changes can you see with your own 2 eyes? The visible light spectrum of helium, look how much yellow light and white light it comes through. So much yellow light it turns white. Okay? But look, green light scatters in helium, and orange light scatters in helium, and where's the green and where's the orange? So you take the green and orange out of your light spectrum when you pass through these clouds of helium. What changes will that make to Neptune? And the recent changes in Neptune show that it got dimmer from what the ones I've showed you and lost its color. It looks more gray. So what would make it go brighter and then suddenly go dimmer? And that would be particle interaction, hot particle interaction in its magnetosphere, creating auroras and brightening the magnetosphere around Venus and Neptune? No, that's not it. It's the particles around the sun, brightening the sun. And if the sun brightened Neptune, it should brighten all the other planets. That's 5th grade again. And one more 5th grade conclusion. If it brightened Neptune, it should brighten all the other planets. It should also brighten the moon. Unless, of course, a wave of particles gets in the way and dims it. So the ultraviolet C being measured all over the Earth is very concerning. At 160 and 180 nanometers, most of these measure 200 to 250 nanometers. But those smaller wavelengths means more energy, and they penetrate further into your skin. They inflame your brainstem, hence the rage, hence the sensitivity to anything that can affect the brainstem, such as pharmaceuticals and opiates. And the horrible thing about this stuff is it's reflective. Imagine this V overlapping itself a dozen times. The arrows going up at some point would meet the arrows going down, creating a concentration of arrows of where those waves meet. Kind of like when 2 ocean waves come together and the wave grows twice its size, twice the energy. So if you park a car in the sun next to a wall, you literally are killing and sterilizing what's ever on the inside of the car. If there's hot sodas in there, they could blow up. Cigarette lighters could blow up. Batteries can blow up on GPS. And people measure this on the ground, and they don't know where it's coming from. And I keep showing you over and over where it's coming from. This is what they're measuring. This is what they're measuring on the ground, 250 nanometer. And solar minimum of 2008. We go from 0.056 to 0.075, 0.058. Oh my gosh, 0.058 up there. That is a huge increase. That's almost 1 trillion watts. It really is. In increase, just in the increase of ultraviolet B. You're not going out the decimal points, and your units are scaled bigger. You're looking at You're looking at almost 1 trillion watts increase. Visible light. We're measuring now the light spectrum of visible light that when you shine it through lithium, lithium will glow this orange. Now, the reason you look for lithium, because it's proof, it's the smoking gun, it's absolute proof. There's a brown dwarf nearby because lithium is the fingerprint of a brown dwarf, and that's how you tell that you're looking at a brown dwarf. You put a spectroscopy on it, and you measure the visible light, and if you get the light spectrums of lithium, you got a brown dwarf. So all of a sudden now, if this lithium gets focused into the sun before it decays, then you're going to see an increase in the very light that the helium's supposed to be absorbing and scattering. So if you see an increase in orange light, which is right before your eyes, if you see an increase in orange light, it cannot be coming because of the helium cloud. The helium cloud takes it away. It's what's traveling with the helium. And you go to all of those cosmic ray measuring instruments, try to find helium and lithium counts that are current and that carry you all the way through to today. You won't. But the very far right hand of the graph is solar minimum. Not any solar minimum, the grand, the magnificent, the great solar minimum. And the energies coming off the sun are trillions of watts higher just in the increase since 2010. Just since 2010. Because you can measure the 2007 increase, and then you take the 2017 levels, which is the very far right-hand side, solar minimum. 2017 is solar minimum. And you see a huge swing in the energies. And again, you're looking at 1 billion watts of extra energy coming off the sun since 2010 or 2007 if you like. So, in retrospect, it's the bottom line. It looks like we hit that pocket in January, early February, and came out and were exposed to that helium the whole way through since. So we got to see what's going on since then. We got a whole month to look at here, and we'll figure it out. But we might be able to tell exactly where this brown dwarf is. This is the 180. This is really destructive stuff, and when you compare it to the other energies, it may not look like it's gone up as much, but it's nasty stuff. It's really nasty stuff. It will shred your DNA. It really will, because of its size of the wavelength. Your DNA base pairs are separated by 30 nanometers, roughly. So 30 nanometer radiation will destroy your DNA at just one base pair at a time. But this will take out 6, 7 base pairs at once. It's like taking 6 links out of a chain, not just one. And that's not good. And so all this extra energy, people measure it on ground and they're like, well, I don't know where it's coming from. But now we know it's particle collision, electron exchange, and particle interaction. We talked about electron exchange producing gamma. Now we're talking about collisions producing extreme ultraviolet. All a broad range of extreme ultraviolet and ultraviolet A. And lo and behold, we see a 10-fold increase in helium count now. And we see the ultraviolet going through the ceiling, and somebody doesn't even want to tell you it's related. That's a crime. It really is. And the fact that this red graph, you've seen it way too many times, it's really done with purpose as well. Because those other channels that refuse to show you that graph must be doing so for a reason. Because we made it so obvious that now even mainstream comes around. And notice how our disclosures run 2 to 3 years ahead of mainstream. But the ultraviolet C, we've only been really hammering it on for a year. And the cosmic radiation. So hopefully it'll come out and we can start developing shade as an industry and exporting shade. And remember, if Neptune's brighter, everything else has to be brighter. That's 5th grade science. So don't let a collegiate level astronomer talk you out of what you already know to be true. In fact, if you listen to him and you go out in the sun and you get injured, I want to know about it. Until next time, be prepared, not scared.